welcome back to our machine design series, where today we are continuing our discussion of gears by focusing on spur gears and some of the terminology associated with those types of gears. So if you remember in our last video, we established what a spur gear set looks like, and remember that spur gear sets are composed of gears that have teeth parallel to the axis of rotation, and they are used to transmit motion between parallel shafts. And remember that if our pinion, which is again the smaller gear, is rotating clockwise, then that means our gear in blue is going to be rotating counterclockwise. Now, one of the first things that we are going to need to define are a few radii that are associated with the sizes of these gears. And so if we take a look at a diagram like this, which is a simplified version of the gears pictured here, then we can define the base radius or the dedendum radius, the addendum radius, and the pitch circle radius. So let me label those. So here I've labeled a few of the dimensions on our simplified model of these spur gears. So first you'll notice that I labeled them gear 1 and gear 2 just to go along with the subscripts. Gear 1 is moving with angular velocity omega 1, gear 2 is moving with angular velocity omega 2, and then I've labeled the base circle, which is in the solid line for each of the gears, and I've labeled the pitch circle, which is this dotted line. And you'll notice that the pitch circles are the ones which actually touch at a point here. This is the theoretical point of contact between the gear teeth on each of the gears. And this pitch circle is a theoretical circle that is going to be used for many calculations associated with gears. It is not associated with either the base of the teeth nor the top side of the teeth. It is going to be somewhere in between. So let's take a look at a zoomed in view of some of these gear teeth to try to understand where exactly we're looking. So if I were to zoom in, actually let's put it up here, zoom in on the teeth up here on top of this pinion gear, might look something like this. Okay, and let's label a few things on here. So this dotted line down at the base here, this is that base circle, which is also sometimes called the dedendum circle. This top line up here is a circle associated with the top of the teeth, and we call that the addendum circle. All right, and then we can label the pitch circle as this dotted line here. So you can see that it ends up being somewhere between the top and the bottom. It's not necessarily halfway between. There are ways that we can calculate what that pitch circle is, and we'll talk about how to do that in just a second. But for now, just know that it is the theoretical circle that has the contact point between the two interfacing gears. All right, let's label a few other things that we will be interested in for these teeth. First, we have the face width of the tooth, which is this distance across the width of the tooth. We call that the face width. And then let's also label the circular pitch, which is going to be the distance from the same sort of point on one tooth to that point on the next tooth along the pitch circle. So I know some of this terminology is a bit confusing, but maybe once we have some equations to look at, it'll make a little bit more sense. And lastly, let's label the tooth thickness. Okay, and you have a diagram similar to this in your textbook. It's figure 13-5. If you want to see it in more detail, there are a few other things that are labeled in the textbook that I've not labeled here. I'm just labeling the things that we are about to use in some equations for different spur gear terms. So let's start writing out the definitions of some of these things that we've labeled on our diagrams here. All right, so let's talk about this pitch line velocity for a second before we move on to more terms. The pitch line velocity, as it says here, is tangent to the pitch circles and has this given magnitude. Remember, we discussed this a little bit in the last video, that the velocity of the tooth at this contact point, this velocity here has to be the same for the tooth on gear 1 and for the tooth on gear 2. That velocity is the pitch line velocity, and it's equal to omega 1 times r1, which is also equal to omega 2 times r2. And this is the basis for things, this is the basis for what we called the angular velocity ratio, because if we know that, let's just use this space up here, if I know that v is equal to omega 1 r1 is equal to omega 2 r2, then I can divide both sides, let's say by omega 1, and I get that r1 is equal to omega 2 r2 over omega 1. Now let's divide both sides by r2, and we find that r1 over r2 is equal to omega 2 over omega 1. And this ratio is also what we defined as the angular velocity ratio, mv. So that's sort of where that all comes from. It comes from the fact that these teeth, when they are at the point of contact, they must be moving with the same pitch line velocity. All right, now let's define a couple more things. All right, so now we've defined circular pitch, which is the distance along the pitch circle from a point on one tooth to the corresponding point on the adjacent tooth that we've already labeled here in our drawing. And then we've noted that it is the sum of the tooth thickness, which we have labeled here, and the width of space. So I forgot to label this, but you can see that it would be this distance here, but measured along the pitch circle. So maybe I want to label it out here. Okay, and the tooth thickness plus the width of space is going to be equal to the circular pitch. We can also calculate the circular pitch by multiplying pi times the pitch diameter. So remember, that's 2 times the pitch radius, and divide that by the number of teeth on our gear. All right, just 2 more definitions and then we will wrap up this video. The first is the diametral pitch, which is closely related to circular pitch. All right, so as we've written here, the diametral pitch is the ratio of the gear's number of teeth to the pitch diameter. So we can use this equation given here to find the diametral pitch, and that is going to be given in units of teeth per inch, which you may also see abbreviated as TPI. And this is a designation that is only used, as far as I know, in the United States. In other countries which use SI units, they will, instead of defining a diametral pitch, they'll define the module. All right, and so the module, as it says, this is just the reciprocal of the diametral pitch. So it is the ratio of the pitch diameter to the number of teeth on the gear, or the circular pitch divided by pi, and it will be given in units of length. It's only used in SI units, so those units will likely be millimeters. All right, so those are a few definitions, terminology associated with spur gears. And in the next video, we will start talking about the shape of gear teeth and the way that those teeth interface with each other, the contact forces that act on the tooth surfaces, the pressure angle between them. We'll talk about some meshing considerations in the video after that, and then finally we'll get to gear trains. So I hope that you found this video useful, and I look forward to seeing you in the next one.